Good morning, fourth graders. This is your math evening lesson for Thursday, April the 23rd. We're going to be looking at lesson 123, equivalent fractions. Let's take a look. The same fraction of each circle below has been shaded. We see that different fractions are used to name the shaded parts. So what you should notice here, the 5 circles, they're all drawn of the same size, and in each circle, the same portion of the circle has been shaded in. Okay, only each time the circle itself is divided up into a different number of parts, a different number of pieces. Let's take a look. The first one, the circle is divided up into 2 equal parts. One part is shaded in, so 1/2 of the circle is shaded. In the second circle, this circle is now divided up into 4 equal parts, and 2 of those parts have been shaded in, 2/4. In the third circle, the circle is divided up into 6 equal pieces. 3 of those pieces have been shaded in. 3/6 is shaded. In the fourth circle, you have 8 equal pieces. 4 of those pieces have been shaded in, so 4/8 of the circle is shaded. In the last one, we have the circle divided up into 10 equal pieces. 5 of those pieces are shaded in, so 5/10 is shaded. So for each of these, again, you see that the same portion of the circle has been shaded in. What has changed is the number of pieces that the entire circle has been divided up into. And these are all what we call equivalent fractions. Okay, as it says here, these fractions all name the same amount. Different fractions that name the same amount are called equivalent fractions. So these fractions are all equivalent. They are equal to one another. So we have 1/2 is equal to 2/4 is equal to 3/6 is equal to 4/8 is equal to 5/10. All of these are equal to one another. They are equivalent fractions. Also, if you remember in class, we talked about how whenever the numerator of a fraction is half of the denominator, we know that that fraction is equal to 1/2. And you can see that's true for each of these. Here we have 3/6. 3 is half of 6. 3/6 is equal to 1/2. And you have 4/8. 4 is half of 8. 4/8 is equal to 1/2. And 5/10. 5 is half of 10. 5/10 is equal to 1/2. So again, anytime the numerator is half of the denominator, you know right away that that fraction is also equal to 1/2. And again, all of these fractions are equivalent to one another because you can see that the same portion of each circle has been shaded in. The only thing that has changed is the number of pieces the entire circle is divided up into. All right, the top of the next page, example 1. The rectangle on the left has 3 equal parts, and we see that 2 of those parts are shaded. So we say that 2/3 of the figure is shaded. Here's your rectangle. It's divided up into 3 equal parts. First 2 parts of that rectangle are shaded. So 2 out of the 3 parts are shaded. 2/3 is shaded. Now over here, we have the same size rectangle, now divided up into 6 equal parts. And you can see that you have the original first 3 parts, but now by drawing a line horizontally, we've divided it up into 6 equal parts. So you can see that it would take the first 2 sections to equal the first section here, and then the middle 2 sections to equal the second piece here. So if we've shaded in those 2 sections, what we have shaded in is 4/6 of that rectangle. So that 2/3 and 4/6 are equivalent fractions. Again, it's the same amount, it's just that in each of these rectangles, the whole rectangle is divided up into a different number of pieces. 3 pieces versus 6 pieces. 2/3 shaded, 4/6 shaded, but they are equivalent fractions. Example 2. What equivalent fractions are shown here? Okay, so here we 2 pieces shaded in as opposed to here where there's only 1 piece. Well, here this rectangle is divided up into 4 equal parts, and this rectangle is divided up into 8 equal parts. And we can see that written here. Here we have 2/8 shaded, and here we have 1/4 shaded. 2/8 is equal to 1/4. 2/8 is equal to 1/4. Or we can say that 2/8 is equivalent to 1/4. Okay, I'd like to take a look at some more examples. This is not in your book, but something that I do want us to take a look at together. So here we have circles. The first circle, as you can see, has been divided up into 3 equal parts, and one of those parts is shaded, 1/3. Well, if we take the same circle, the same portion is shaded in, only this time we have a circle that is divided up into 9 equal parts, and we need to see then how many of those pieces are shaded in. We have 1, 2, 3 pieces shaded in. So 1/3 is equal to 3/9. Again, it's the same portion, okay, but here this circle is only divided up into 3 pieces. Here it was divided up into 9 pieces. Okay, let's look at the second one. Okay, the second one, they actually did the 1/4 first, and 1/4 goes with this circle. Okay, this circle is divided up into 4 equal parts. One of those parts is shaded in. So now on this circle, we have the same portion shaded, but now we have to look to see, well, how many pieces does this circle have altogether? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 equal pieces, and you can see that 3 of those pieces have been shaded in. So 1/4 is equal to 3/12. Okay, let's go to the next one. Okay, here they're showing 2/3 first. Well, that goes with this circle. It's divided up into 3 equal pieces. 2 of those pieces have been shaded in, 2/3. In the second circle, the same portion is shaded in, only this one is divided up into a different number of pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this circle is divided up into 12 equal pieces. And now we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 of those pieces have been shaded in. So we can see that 2/3 is equal to 8/12. Okay, same portion, just different number of pieces. Okay, we go down to number 4 here. Okay, number 4 lists 3/4 first, which goes with this circle here. Okay, this circle is divided up into 4 equal parts. 3 of those parts are shaded in, 3/4. The same portion is shaded in on this circle, only this circle is divided up into a different number of pieces. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 pieces here. And then you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those pieces have been shaded in. So we have 3/4 is equal to 9/12. And then the last one here, 1/2 has been shaded in, 1/2 has been written first, and here 1/2 has been shaded in. You have 2 equal parts, one of those parts is shaded, 1/2. Now this circle, again, the same portion has been shaded in, only this one has a different number of pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 pieces that have been, that the circle has been divided into, and we have 1, 2, 3, 4, 5 of those pieces that have been shaded in. 1/2 equals 5/10. And again, anytime your numerator is half of the denominator, an equivalent fraction for that is 1/2. Okay. All right. Your practice here down at the bottom of page 423 in your math book, your practice asks you to name the equivalent fractions shown, and you can see in the first example you have a rectangle that is divided up into 8 equal pieces. 6 of those pieces have been shaded in, so that's 6/8. And then in the second rectangle, you have 4 equal pieces, and 3 of them have been shaded in, so you have 3/4. So you actually have 6/8 is equal to 3/4. Okay. And then in figure B, your rectangles, you have the first one that is divided up into 9 equal parts. 3 of those parts have been shaded in. And then the second rectangle, you have 3 equal parts with 1 part shaded in. So we have 3/9 is equal to 1/3. 3/9 is equal to 1/3. Okay? All right. And then you can work on your own at the bottom where it asks you to draw pictures to show that the following pairs of fractions are equivalent. So if you would do that on your own, please, drawing pictures to show the following pairs of fractions are equivalent. One of the things that you need to remember in drawing equivalent fractions is that the figures that you start with both need to be the same size. So if you're drawing a square, a rectangle, or a circle, it doesn't matter. It's just what matters is that they are both the same size. And when you're doing equivalent fractions, you use 2 of the same figures that need to be the same size. Okay, you must make sure they are the same size and same figures so that you can very easily show that overall you have the same size figure, and it's easy to compare the number of parts that you have. Okay. All right, so today's lesson in Saxon is lesson 123. So you need to complete all of the lesson, and there are 30 problems. Okay, so lesson 123, equivalent fractions. You need to do all 30 problems, and there are 3 of the practice that you need to do your own, C, D, and E, where you need to draw those figures and shade them in appropriately. Okay, and don't forget, spend some extra time on IXL or extra math, whatever it is you're working on. And if you have any questions or need my help, please make sure you reach out to me. I'll see you later. Bye.